This is the test arena for autonomous systems. We are testing our underwater drone. The seals are simply stealing the fish from the fishers. And that's where our group comes into play. So we want to help the fishers, not by shooting the seals, as some others suggest, but by inventing new gears and modifying existing gears so they become seal-proof. And this can happen in different ways. So first we have passive gears, like the gillnet, for example, is, meaning that the fish comes to the fishing gear. And one alternative we are testing here is fish pots, fish traps. And the idea of these fish traps is that they are actually fish traps which have some bait in, and the bait is supposed to attract the fish to swim inside, and so they are captured in the trap. The entrances need to be limited so that the seals cannot fit through the entrance of the fish pot, but the fish still can. Netting needs to be very tight all around the pot, that the seals cannot push the netting and so still reach the fish. And then we are also testing an active alternative gear. Active meaning that the fishing gear is coming to the fish. And the gear we are testing here is a mini sail, so that we, in the end of the project, can hopefully present a well-functioning fishing gear which can be used in the Baltic, but also in other places, actually everywhere where there is problems between the seals and the fisheries. In the beginning of the year, for example, we have been out in the Fehmarn Belt, where we have been fishing with the seine, and we looked at how different hauling speeds affect the catch efficiency for different species. But since we had the opportunity, we of course also looked at data for selectivity. Selectivity in terms of sizes, but also in terms of species. And this actually brings me back to the ICES working group on size and species selection experiments.